Hello friends, I'm Sahil Abbas from JNTUH Hyderabad from the Department of CSE, having roll number 2401180572. I will be demonstrating on DC shunt motor. DC shunt motor principles and applications. This presentation will explore the principles, characteristics and applications of DC shunt motor, a versatile and widely used type of electric motor. Introduction to DC motor. Direct current DC motor. DC motors operate on the principle of interaction between magnetic field produced by a stationary field winding and a rotating armature winding. They convert electrical energy into mechanical energy, providing rotational motion. Types of DC motor. DC motors are classified into various types based on their field winding configuration, including shunt, series, compound, and permanent magnetic motors. Construction of DC shunt motor. Field winding. The field winding is connected in parallel shunt with the armature winding. It's typically made up of wire with high resistance, creating a strong magnetic field. Second one, armature winding. The armature winding is wound on a rotating core rotor. It's connected in a parallel with the field winding and carries the current that produces the rotating magnetic field. Commutator and brushes. The commutator and brush facilitates the transfer of current from stationary conductors to the rotating armature. They ensure continuous rotation by reversing the current direction in the armature winding. Operating principle of DC shunt motor. Current flow, magnetic fields, torque, rotation. When current flows through the field winding, it generates a magnetic field. The armature current also creates a magnetic field that interacts with the field winding's magnetic field. This interaction produces a torque that rotates the armature, resulting in mechanical output. Speed torque characteristics of DC shunt motor. First one, high starting torque. Second one, constant speed. Third one, linear decrease in speed. DC shunt motors exhibit a high starting torque due to strong magnetic field produced by the field winding. At constant armature voltage, the speed remains relatively constant even with the change in loads. As load increases, speed decreases linearly. Advantages and disadvantages of DC shunt motor. Constant speed. DC shunt motor maintain a relatively constant speed under varying load conditions. High starting torque. They can provide high starting torque to overcome initial load resistance. Good efficiency. Shunt motors generally exhibit good efficiency due to the parallel connections of field and armature windings. High cost. DC shunt motors tend to be more complex and expensive compared to other motor types. Applications of DC shunt motor. Industrial machinery. They are used in various industrial applications, requires precise speed control such as lathes, milling machines and conveyors. Electric vehicles. DC shunt motors are employed in electric vehicles, providing efficient and reliable traction for electric cars, buses and trucks. Elevators and cranes. They are used in lifting applications like elevators, cranes and hoists due to their high standing torque and speed control capabilities. Speed control of DC shunt motor. Armature voltage control. Varying the voltage applied to the armature winding changes the motor speed. Field current control. Adjusting the field current alters the strength of magnetic field, affecting the speed of the motor. Series resistance control. Adding resistance in series with the armature winding increases the voltage drop, reduces the speed. Maintenance and troubleshooting. Regular inspection for signs of wear, damage or loose connections. Lubrication. Lubricate brings and other moving parts are necessary. Brush replacement. Replace worn or damaged brush to ensure proper communication. Commutator cleaning. Clean the commutator to remove dirt and debris. Conclusion and key takeaways. DC shunt motors are essential in various applications due to their advantages like constant speed, high starting torque, and good efficiency. Understanding their operating principles, speed control methods, and maintenance requirements is crucial for efficient and reliable operations. As technology advances, we can expect further innovations in DC shunt motor design and applications. Thank you.